should be live, I think. As always, somebody has to tell us that we exist. Otherwise, we won't ever know. I'm seeing that it's live on the other channel, so I'm going to assume that this is working. Come on, there we go. Paranor just let me know that we exist. Hey everyone, say hi in the chat. And look, it's right there. All right. So say hi. So I guess Dave, you're gonna talk about the Geminids. So I was gonna actually get into it, but actually we should wait for the show.
Geminid meteors, yeah.
Yeah.
Peak on the 14th.
Right, which is like a nice full moon.
Yeah, it's not the greatest year, but we had a full moon on 2011, I believe. It was pretty close, and it's a pretty strong shower though. There's ways you can still see them.
And we're like 3 days away from The Expanse, the next season of The Expanse coming back.
I got to catch up on the other season.
Who's caught up on The Expanse? Anyone? Just me? Really?
I got a book to write.
Oh, you do, and I have an intro to write for your book, don't I?
Yeah.
All right. You've had a chance to say hello, so I'm going to say hi to everybody. Hello to Andy Cowley, Astro B, Bill Sugden, Bob Moeller, Christian Woodland, David Fairweather, Emmett Ford, BTT, Eric One, Esther Gagne, Frank Tippin, Gordon Dewis, Ian Farquharan, John Musk, Johnny J, Johnny Zed, Kevin Ayers, Larry Beckham, Nancy Graziano, Neil Yu, Paranor, Rich Wilson, and Zappan. Hey, everybody. And someone else said hi. Astro B. There we go. John Victor. I don't know if I already said your name. And Andy Cowley. Okay, fine. And you. Sorry, I'm reading the chat at the same time that I'm engineering the show. I cannot wait. I really feel like The Expanse is like apart from a magical fusion drive, it's like the most realistic space exploration television show. So, no, I'm super, super excited to see the next season. And my wife has read the books way ahead, so she knows where it all goes. So I'm still totally behind.
It's like Game of Thrones. We don't have to read the books now that we've seen.
Yeah, I stopped. I give up.
Yeah.
Now. All right. 2 more minutes. We'll let everyone take a seat, catch up. Tom Van Scotter, hello.
The next season of Lost in Space comes out on Netflix too.
Yeah, I didn't like it much.
I heard you say that before.
Yeah.
I like the characters. It's kind of cool. It's kind of cool that the kids are smart in that one. I think it's like.
Yeah. What was the other one? I've heard a couple of people saying Ad Astra is not great.
Ad Astra? No, I haven't. I've been waiting to find somebody that has Apple TV so I can watch it.
Oh no, that's the For All Mankind.
Oh, okay.
Yeah, and I've heard that's pretty good.
Yeah, I haven't seen that yet.
In that they blend sort of footage from the Apollo missions and into sort of what they're doing, telling the story that the Soviets landed first.
Yeah, I've seen the premise to it. I've been watching through The Mandalorian too. That's okay as far as Star Wars goes. I guess it's okay.
Yeah.
It's not spectacular, but it's
Lone Wolf and Cub. Is what it is.
There's not a lot of side plot to it. It's just one story.
Yeah.
It took me a while to figure out. It's like, what's wrong? It's like we're used to seeing things with a lot of side plots going on.
Yeah. Yeah. No, I mean, the problem with The Mandalorian is you can't have any critical thoughts on it because of Baby Yoda.
Yeah.
So it doesn't matter because Baby Yoda, right?
There will be a lot of Baby Yodas underneath the tree this Christmas.
Apparently not. They didn't make
really.
And yeah, apparently to keep it a secret, they didn't make the merchandising machine go in full speed. So yeah, to make it a secret is what I had read.
That'll change.
How does Fraser find time to watch streaming services? That's my hobby. That
seems like a bad money move.
I guess. I guess. I don't know.
Yeah.
Like the surprise.
I want one.
If it had been a baby Jar Jar, the internet would be a dumpster fire right now. So.
The internet's already on
Yeah.
Of Baby Jar Jar? Yeah, all right. Okay, we're at the 5-minute mark, so why don't we start up the show? So I'll put you all back away, back on me. Here is my intro. Make sure the dates are all right. Okay, here we go. Hello and welcome to the Weekly Space Hangout for December 11th, 2019. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the Murchison Widefield Array radio telescope. How are the Geminids going to be this year? Global geologic map of Titan and more. As well as an extra special guest, which I cannot wait to talk to. So joining me today on my screen already is the space writer, Carolyn Collins Peterson. Carolyn.
Hi.
Welcome back. Also, we've got Moya McTeer. Moya.
Hello.
There we go. You have to say hello long enough to get the camera to switch over to you. Otherwise, there we go. Yeah, just like a long drawn out hello. And then David Dickinson. David.
Hey there. We have the Christmas tree up. Actually, we had it before the U.S. Thanksgiving. So
you had the Christmas tree up before the U.S. Thanksgiving?
It's the only time when the telescope comes down from that spot and the tree goes up. So telescope's packed away right now.
Oh, okay. And you don't just put ornaments on the telescope like a proper astronomer?
We could, but then it would be kind of unserviceable for about a month or so.
Right. You wouldn't be able to see the things that we're planning to talk about. All right. So before we get into the interview portion, I just want to say a big thank you to all our good friends at the Weekly Space Hangout crew. They are, of course, they are our executive producers. They're our fans. They're our friends. And if you want to be a part of this incredible community, go to wshcrew.space and they will hook you up and make you an executive producer just like them. All right, let's get on to the guest, and this is very cool. I'm joined by Apollo astronaut Charlie Duke. Charlie, welcome to the Weekly Space Hangout.
Thank you very much, Fraser. It's good to be with you.
All right, now you obviously one of the people who you went some interesting places in space. But for people who don't know, who are you and what have you done?
I was a Apollo astronaut. I got to fly to the moon on Apollo 16, and John Young and I spent almost 72 hours exploring the Descartes Highlands of the moon. It was a very exciting mission, and I'm ready to go again.
Well, it's time. I mean, it's just going to be about another 5 years now. So if you
that's what they're hoping for. I don't see a technical problem going back to the moon. It's just getting the money appropriated for NASA anyway. But I'm excited. I think we're doing the right thing, headed back to the moon.
That's interesting. I mean, a lot of people, back during the Apollo era, the amount of the resources of the United States, there was a serious amount of money that was funded to make those missions happen. Comparatively speaking, this is being done on a shoestring this time around.
It seems so, but we've been working a long time on the orbital vehicle, which is Orion. It's been, I remember 10 years or so ago, I was on an advisory committee with Lockheed, and we were looking at it, and they were designing it and building it. And then the Space Launch System is under another budget, unlike Apollo, where it was all lumped in together, the launch vehicles and all of the spacecraft. So I think that we've got a good chance of landing on the moon. Certainly next decade. Yeah, I wouldn't put any money on the next 5 years, but certainly in the next decade, it's doable.
Yeah, even if it takes an extra 4 years, I think that's all right.
Yeah, sure.
Yeah, it's not going anywhere. Well, it's going like a couple of centimeters a year, but apart from that, it's not really.
I think we can handle that.
Yeah, it won't change the math too much. So, but you are working on a company that is going to help people kind of go to the moon. So, can you talk about it?
I'm one of the founders of a company we call Astrograms. And the idea came through me with back in Apollo 16, I took a picture of my family to the moon. And I had two young boys at the time, one 5 and one 7. And I was trying to get them excited about what Dad was doing. And so we took this picture, and I got permission to leave it on the moon. So I dropped this picture on the moon with our names on the back of it. And on the back of the photograph, I said, this is the family of astronaut Charlie Duke from planet Earth, who landed on the moon during in April 1972. And we all signed it. And my kids got such a big a high out of this. And so we've come up with this idea of astrograms, where you can log on to our website and you can fill out an astrogram with a message and sign it and send it in to us, download it to us, and then we'll package it together and put it on a rocket that will take it into space. And we're even working on opportunities to send it back to the moon. So I think we've got a exciting program ahead of us with astrograms.
Now, there are a bunch of, as part of the Artemis program, there's been a bunch of new hardware that's being developed to be able to go back to the moon. So what is the, which lander are you hoping to partner up with to be able to go to the moon?
Well, we're negotiating with several companies, but we haven't got that tied down right now to take astrograms to the moon. Our first launches will be Earth orbital and also the International Space Station. We'll be sending to the space station. Those will go up and stay on the space station for three months or so, and then brought back. We're just getting started, Fraser. So I can't say that we've got a company or lander that's going to take us to the moon, but we're sure working on it.
So what do these astrograms look like?
Well, there'll be aluminum foil, and people will write a message, and you can see them we're launching a website, and click on buy, and it'll all come up and show you how to fill it out, and then you send it to us, and we package it up, and then get it on a payload. One of the launch companies that we're negotiating with.
That's cool. So you can get any kind of message that fits within this piece of foil, and then a bunch of them will be packaged up together and then launched into orbit, and then returned from orbit if they get a chance to go to the International Space Station, and then you'll have a piece, your message that flew in space. And I guess if it does go to the moon, then you probably don't get it back. So that's the downside, right?
Yeah. Well, we'll certainly take a picture of what you did, and that picture with a plaque and a statement and a signed statement from me that it's on the moon, and we were glad that we were able to work with you to get your message into space.
That's pretty cool. And so I've put up the website, and we'll put a link to the website in the show notes and description. And we did Nancy Atkinson did a great profile of the company, so people can find out more information. And of course, that's on Universe Today. So where did the idea for this come from?
Well, as I said, it was a mutual thing. I'm working with two guys, Tom and Andy, and they came to me, would say, what do you think of this idea? And because they remember the picture that I left on the moon, and for my family.
Yeah.
And as I said, it meant so much to my kids that to do this, to have other people be able to get their name and message into space, we decided to, we'll give it a go and see what happens. And we're getting a lot of interest. So I think it's a exciting program to get going with. And we look forward to working with people around the world to get their message into space.
Yeah. I mean, I know there's a lot of like memorabilia and stuff. Like people are picking up at auctions and stuff, articles that have flown as part of previous missions, stuff even from the Soviet missions. I've got a couple of meteorites that I really like that have come from space, and there's something kind of really special about this idea that something flew in space and then made it back down to Earth. Yeah, it's pretty cool. So I'd like to just go back again and sort of talk about your perspective now, sort of seeing what's happening with SpaceX, with the rise of reusable rocketry. You know, how much do you think this is becoming like a paradigm shift in the way spaceflight is going to be done?
I think it's a huge shift. I'm so excited about the private companies that are involved. SpaceX, Virgin Galactic, Orbital, Firefly, and many others that are involved. And I think we're going to see these companies eventually getting man-qualified spacecraft. And I think space tourism is going to explode, actually. And it will be a great a boost for the space programs. And then our NASA program, I think will begin to focus on deep space again, the moon and beyond.
Yeah, explode metaphorically, hopefully. I would love, trying to figure out a way that regular people can actually get a chance to fly in space. A lot of people have sort of bet their companies. Virgin Galactic, as you mentioned. I know Blue Origin is planning with their new Shepard flight, and there's a couple of others that are planning to do this well. And one of the real benefits, I think, is that it gives people this perspective of the planet. That idea of seeing the whole planet as one place without borders, and getting a chance to fly in space is a way to be able to do that. So can you talk a bit about that perspective that you're hoping that people might be able to get?
Well, the perspective I had when we left Earth orbit, we turned our spaceship around to retrieve the lunar module from its launch position. And I'm looking out my side window, and into my window floats the Earth, 20,000 miles away.
Yeah.
And it was breathtaking, awesome. And there it was out there. You could see the whole circle of the Earth, and the Arctic Circle down across Canada, the U.S., Mexico, and Central America was the land we saw. And there were three colors: the brown of the land, the crystal blue of the oceans, and the white of the snow and the clouds. And this hung in the blackness of space was that beautiful Earth. It certainly does change your perspective. We could see Canada, Mexico, U.S., but no borders. It was just there. It was out there. And it was just indelibly imprinted on my mind. I've told a friend of mine who's signed up to go for a Virgin Galactic, I said, when you get into space, don't unstrap. Just look out the window. That'll be the most fantastic sight you'll ever see in your life. And you will never forget it. You can do zero gravity in the Vomit Comet if you want to, but you can't get that view that you're going to have. So focus on looking out of the window of that spacecraft. And it's going to change a lot of people's perspective about our beautiful Earth.
Yeah, I mean, at this point, we're at, say, I don't know, 500 plus people who have their astronaut wings. But if hundreds of people a year can go through this experience of getting a chance to see Earth from a suborbital perspective, but still that point where you get to see that curvature,
right?
The more human beings walking around this planet who can appreciate it from that point of view, I think the better. Charlie, I don't want to take any more of your time, but again, your website, astrograms.com. We will put a link in the show notes and a link. We'll put a link to the profile that Nancy did about the company and what you're doing. Is there a deadline when people need to get their message in before it flies to space?
No, there's no deadline right now, and we're going to hopefully our first launch will be next year, and we'll be signing up contracts with launch suppliers, and so we'll keep going if the interest is there. So people don't have to worry about getting it in, but send them in, be one of the first to go. So we're looking forward to it.
That sounds great. Well, Charlie, thank you so much for taking the time to chat with us today, and let us know when you're flying. And when
we will do that.
And
thank you.
Also, when you get accepted into the astronaut program for the return to the moon, that'll be great.
Well, I told NASA I'm physically qualified, and I told NASA I'm ready. I'm ready to go. But the word I got was, "Don't call us, we'll call you." So
you're saying there's a chance.
Well, at 84 years old, I don't think they're going to need me.
All right. Thanks a lot, Charlie.
Thank you.
All right. Let us move on to the news portion of today's episode. Moya, what do you got for us?
I am going to talk about Titan today. So last month, the ESA, the International Cassini Collaboration, released a global geological map of Titan, which is one of the moons of Saturn. It's actually Saturn's biggest moon, and it is really beautiful. If you haven't seen a picture, it's absolutely gorgeous. It shows different features on the moon, color-coded by what type of feature it is. And I saw it and was amazed, so I wanted to talk about it. I don't know if you're pulling it up. There you go. Yeah, it's absolutely beautiful. So for some context, Cassini is the spacecraft that was responsible for this map. Cassini was launched in 1997. It was an international collaboration sent out to take images of Titan or get a lot of different types of data for Titan. It took about 7 years to reach Saturn, so it got there in 2004 and then spent 13 years orbiting the planet, dipping in and out of its moons and its rings and gathering so much information. It had 12 instruments on board. Those instruments were various types of imagers, so they were taking pictures. They had spectrometers and spectrographs, so they were analyzing the chemical makeup of different things that are orbiting Saturn. It had a magnometer to measure magnetic fields. It had a radar system, so it was stacked. It had a lot of different instruments on board to collect as many types of data as possible. It ran out of fuel in 2017, and to avoid contaminating the solar system with any type of life that might have hitched a ride on board, because we know about those pesky tardigrades that can survive space, they sent it crashing into Saturn. So it ran out of fuel, they crashed into Saturn, and that way no life will be found out in the solar system that came from Earth. In the 13 years that it was orbiting Saturn, it did 120 flybys of Cassini. And Cassini is a really interesting moon because it's
Titan,
Saturn's biggest. Oh, right. Titan. Titan's really exciting because it's the only other body in the solar system that we know has stable liquid on its surface. And it's not liquid water, but it's liquid methane, which is interesting. And so using a combination of radar and imaging and infrared technology, they were able to break through Titan's atmosphere to figure out what its surface looked like. And they found a bunch of different stuff. So they saw lakes, methane lakes. They saw dunes, plains, craters, mountains, all of these different types of geographic features. They even found some interesting results. So if you look at that map, it's color-coded by the type of feature that you see, and you can see a trend. So the dunes are concentrated around the equator. On the map, the dunes are like purplish, and the lakes are closer to the poles, and then other things like the plains and the craters are in the mid-latitudes. They were also able to figure out the relative ages of the different features, and they found that the mountains are much older than the dunes and the lakes, which makes sense because it takes a long time for mountains to form, and lakes and craters and dunes of something like sand can be formed relatively quickly.
But it all gets weird, right? Because the mountains are made of ice, right? It's not dirt in the way that like everything's shifted one level on Titan.
There.
It's colder there. Yeah. And so you've got sand made of ice and seas filled with methane, and it's such a bizarre place. And yet it seems like it would feel so familiar.
Right. Yeah. If you can get over the fact that everything is made out of different stuff, then it might look very, very similar to Earth.
Yeah.
Yeah, so I have a few friends who study Titan and are involved in the Dragonfly mission, which was selected to go to Titan, and it will get there in 15 years. So we have this map now, and hopefully we'll have a better one then.
So, I mean, from a exoplanet perspective, when you think about other planets out there and then think about Titan, sort of how do you connect the two?
Yeah, so when astronomers are looking for life out there, they tend to look for liquid water. Water because it's the universal solvent. If you're going to try and make life, then you need a type of soup that can take things apart and then put them back together to create the building blocks of life. I think that Titan is really interesting because we know it does have some type of liquid that's stable on its surface, and maybe that liquid isn't as much of a solvent as water is, but it can still get things done. I do think that Titan isn't the best. It's not the front runner for life out in the outer solar system. If you're looking for life there, you're probably going to be focusing more on Enceladus or Europa, the moon of Saturn and Jupiter, respectively. But, I'm not going to rule out Titan.
Yeah. I mean, it's such a bizarre place, though, and to have like this, such a thick atmosphere, even thicker than the Earth's atmosphere, such a bizarre landscape, and it was really thanks to Cassini with that ability to peer through those clouds. If I remember correctly, before I think the Voyager mission, they weren't even sure that Titan. They thought Titan might be bigger than Ganymede, because they weren't sure how much cloud there was. So it was so little they knew about this place until they finally got a chance to fly there.
They routed Voyager 1 specifically to fly by Titan, but of course then it got ejected, so it didn't do the grand tour like Voyager 2 did. But Voyager 1 didn't have the instruments that Cassini had, so it just saw kind of a blank.
Yeah, it's even more ironic than that. They could have either done a flyby of Titan or been able to use Voyager 1 to go out to Pluto.
Yeah.
So in the end, they decided they were going to do the flyby of Titan because it was bigger,
high priority enough.
It was a higher priority, and it was closer.
They wanted to get a look at it.
And ironically,
Titan was interesting.
Yeah.
And they knew since, I believe it was Gerard Kuiper back in the 50s first detected the atmosphere. So they knew there was something interesting going on there. But Voyager 1 didn't see that much.
So Moya, what does a geological map like this do for astronomers? What's their, how does this help them out?
Yeah, well, knowing the geography of a world helps you figure out its history. You can learn things about the internal mechanisms going on in the planet, like whether or not it has plate tectonics. And I unfortunately don't know enough about Titan. It doesn't have plate tectonics. No, but I don't know enough to give you a detailed history of Titan's geology or geography. But that's why it's interesting. If you see that it has these mountains and these different features, and you get a sense for how those formed, which then tells you more about other bodies in the solar system, basically what is possible for different bodies that can form in space.
Yeah, and the other part that's really crazy about Titan is how, it might be have as much water or be sort of in a similar situation as Europa or Enceladus. It's just that it's then also surrounded by this additional layer of methane and has this atmosphere as well. But there could entirely be an internal water ocean as well. And one of the big mysteries is could there be some process that's moving water from the inside to the surface somehow? Could there be cracks, geysers, things like that? And then vice versa. So it's like you've got in the methane and a lot of the complex hydrocarbons, you've got all of these raw chemicals for life that are being mixed in these really interesting ways. And then underneath the surface of what could be tens of kilometers thick of ice, you've got this perfect environment for life. And then the hope is, and the question is, could there be some mechanism that's getting material from the surface into the undersea ocean, and vice versa? And if you can, and this is one of the big mysteries that, for example, Dragonfly is going to help solve. And of course, every time I think about the idea that there could very well be a quadcopter, a nuclear-powered quadcopter flying around on Titan, I cannot wait. It's too bad Titan is so far away. It's like hands down, if you said like you can only send one more mission, it would be something to Titan for me. Absolutely. Yeah. Within the solar system. Yeah. But if I only get one.
I love these types of missions because they do take so long, which means it's like in terms of scientific careers, it requires multiple generations of scientists.
Yeah.
And so the people who are working on Dragonfly and are really vital to the Dragonfly mission are early career people, because they have to be if they're going to see it through. And then more people will join the mission later on, and more people will analyze the data once we get it in more than a decade. So I love these missions for that.
Yeah, totally. All right, David. Tell me about this upcoming meteor shower, the best meteor shower of the year.
This weekend, we have one of the top surefire annual meteor shower draws. It's the Geminid meteors that are named because they come from the constellation Gemini. The radiant is right up near the bright star Castor of the twins, Castor and Pollux. However, this year, the Geminids are going to be a little bit of a challenge because the moon is reaching full in just a couple hours, actually. So it's going to be waning gibbous, and it's going to be in the constellation Gemini, like 8 degrees from the radiant at the same time. But this is a pretty strong shower. This is it surpassed the Perseids probably at the beginning of this century. Actually, the Perseids always have been the top draw in August. This one generates anywhere from 100 to 200 per hour, but it seems like the Geminids are evolving, because it's the first time this shower, a lot of meteor showers, like we have records of the Perseids and the Lyrids and things going back thousands of years, like Chinese astronomers have watched these showers. The Geminids were first noticed in around 1860, and they were kind of an obscure shower at that time, but it seems like we haven't seen the best of them, because in recent years, they've been getting really good. And one thing that's kind of cool, where most meteor showers you have to watch early in the morning because the Earth is faced forward into the radiant, kind of plowing into the meteor stream. The Geminids the angle is steep enough when they're coming into the Earth, where the Earth intersects it, that you actually start seeing some of these I start seeing Geminids toward 10 or 11 p.m. before we're turned all the way forward. So you don't have to stay up that late to watch them.
So can you talk a bit about that idea of the orientation of the planet? Because I think a lot of people, when they think about meteor showers, they wonder like when you should go and look, what's the best time.
Yeah. And I always get that on Twitter and online.
Yeah.
It's like, well, I went out and didn't see anything, but a lot of times people go out when they're active, they go out in the evening. The Earth, past midnight, we're faced forward into our orbit. So past midnight until noon, but of course the sun is up, so you're not going to see anything after sunrise. We're faced into the orbit, plowing in. You think of it, think of the front of, you're going down the highway, the front of the car always gets the mosquito splatters on it. Or up north, it's like when you're going into a snowstorm, you get that Star Trek effect with the snow coming at you. Think of the snowflakes as the meteors coming inbound. That's the inbound stream. Now, most streams, you get it where it goes head on. But like I said, there are a few showers. There's another rarer shower around December, around the winter solstice, coming up here around December 21st or so, called the Ursids, that actually comes in at a 90-degree angle. I wrote about them briefly too, because that's an interesting shower. It's not as well known, but this year the Ursids fall right around new moon, so you might see some of those. It's got a much sharper peak that's only a couple hours long though. Like the quadrantids that come right after New Year's they're very elusive because it has the peak is very brief. What you're seeing, of course, this is dust particles from, well, in the case of the Geminids, usually it's a comet. The object that the Geminids, known as the progenitor source of the Geminid meteors, it seems to be an inactive, they call it a rock comet, you see. It seems to be an inactive comet nucleus that got caught around the sun called 3200 Phaethon, which is kind of a really unique object because it passes closer to the sun than any named asteroid. It passes about 1/3 of Mercury's orbit, like I think it's like 0.18 AU to the sun. So it passes very close. It seems like this thing is getting frozen, then baked, then frozen, then baked, because it passes, its aphelion was out past Earth's orbit. So its aphelion's a little over 1.08.
And so why do sometimes we get like a prediction of a really strong meteor shower, and then other times we don't get a prediction of a strong meteor shower?
Well, they're annual, of course, because you're passing through the stream right where that path of that comet, or in this case, this rock comet, this inactive nucleus is intersecting. But also planets like Jupiter mainly are also these streams, these ancient streams that are laid down, they're evolving mostly due to the gravity of the other planets out there that are kind of like the Leonids. We see a strong storm. We see a weak one around mid-November every year, but we see a really strong storm every 33 years. In these streams, people that study these things, they know that the orbits of the other planets are slowly, like they'll say, like we're going to be intersecting the 1611 stream or something like that that's been laid down.
And so like every time the comet or asteroid does its circuit, it lays down a new stream
of these fine dust.
And those streams, based on various past storms, have been mapped out by astronomers. And so then as the Earth is going around, because sometimes it's a little higher and sometimes it's a little lower and sometimes a little to the left and sometimes a little to the right, and the streams are moving as they're turning around, and everything is, it's all...
You might remember last month we were all excited about the Alpha Monocerotids, that there was a stream that was predicted, there was some enhanced activity. It wasn't anywhere near meteor storm. Meteor storm is usually put toward a zenithal hourly rate of maybe 1,000 per hour is the cutoff. And I've only ever seen that for myself when we saw the Leonids from Kuwait in 1998. I think towards sunrise, we were pushing 1,000 per hour. It was pretty impressive.
In the chat, Esther Gagne is asking, can you see meteor showers in light polluted areas? So do you want to talk about that and also talk about the stupid moon?
You can, and the moon is the primary source of light pollution this time around. Of course, that's natural. What I like to do in a case like this is maybe try to block the moon behind like a building or a hill, because it's near the radiant, but you're not going to see most of the meteors that you're going to see are going to be in profile about 45 degrees from the radiant off to the side, most of them. So if you can block it behind something while you're observing, I'm probably actually looking at the weather here, although the peak is Saturday morning. I'm probably going to go out tomorrow morning and watch, because I think we're going to get clouded out for Friday and Saturday. So, this has got a really broad peak, so it's worth watching a day or two on either side. And plus, the moon should be set toward early morning. I'll probably get up about 4 o'clock or so, and it should be down low. But yeah, try to find somewhere. I'm observing actually from downtown Norfolk on our parking garage roof, which is pretty light polluted. But I know some areas that I can kind of get blocked off away from the street lights. Because that's another thing I hear people always say. It's like, why didn't I see any meteors? It's like, well, light pollution. If you notice in the first book, I did a graph that actually shows the percentage of meteors goes down drastically the lower the radiant is in the sky. That's why we say zenithal hourly rate. That's always the ideal amount if you're under a perfect dark sky with the radiant right at the zenith, which most of us don't have. So the radiant, the lower it is, you're going to see less meteors. You can't really do nothing about that except change your observing latitude. And light pollution is going to kill meteors dramatically. So
yeah, but it's going to get rid of the faint ones. You're still going to get the bright ones.
Oh yeah, yeah. You'll still get the fireballs. And Geminids, from what I've seen before, produces some meteor showers. Produce a lot of faint meteors, but not a lot of fireballs. There seems to be a lot of fireballs. The Torrents in November are notorious for, they're known as the Torrid fireballs, that there's a high ratio of bright fireballs associated with the Torrids are associated with Comet, I think 2P Enki, I'm pretty sure.
And one fireball is worth a whole night of really terrible meteors. Right? Like one fireball, just like it lights the landscape up around you. No light pollution is not a problem, you know, because it's so bright. It's totally worth it. When
we saw the Leonids in Kuwait, toward sunrise, we were seeing a fireball like that once every few seconds.
Yeah.
Enough that you could see your shadows cast and you knew there was one behind you didn't see.
Yeah.
So that was pretty impressive.
And it's interesting. So you were in like perfectly dark skies for that one. I was in the middle of Vancouver, right in the middle of light pollution, right downtown. And it was an impressive storm for me to see it from Vancouver.
Ironically, I was at a forward deployed military base. I was in the Air Force at the time, and they tend to keep those with the lights out just for security reasons. So, and I've heard guys that have gone to Afghanistan and stuff say too that it's actually they've never seen the skies like that before because the military bases over there are generally they're kept blacked out. So,
wow, that's yeah, that would be that. You must have got a lot of great stargazing done while you were in the middle of the of the desert.
Yeah,
when they weren't putting you to work anyway. Well, thanks, David. Carolyn, what do you got for us?
Well, you were talking to me about the Murchison Widefield Array, so I thought I think you talked about it once in the last week or so.
A couple of weeks. I feel like I talked about it on maybe an astronomy cast. It was like, and we also did a bunch of reporting on Universe Today about it. I'm pretty excited about what they've been up to.
Well, okay, so I got involved with it about 10 years ago. I was living in Massachusetts, and MIT Haystack Observatory was involved in creating the dipole antennas for this thing. And originally they were going to build out about 512 dipole antennas across all these, what they call tiles. They just build them out on, put 16 dipoles to a tile. And the idea is that in radio astronomy, of course, we have a lot of astronomy that's going on at the higher frequencies, but nobody was really going and looking in the 80 to 300 megahertz range. The big reason being that there's a lot of broadcast that goes on in the middle of that. It's highly sensitive to radio frequency interference. So you have to build these places, like almost all radio telescopes, they got to be built out in the middle of nowhere. So this one is built about 800 kilometers outside of Perth, Australia, in the Western Australian outback. And it's been rolled out in two phases. So the first phase was completed in about the 2013. They had 128 tiles out there. I think they've now extended it out to about over 300 tiles. And it's looking at things in very low frequency range. And the story that caught my attention the last couple of weeks was there's a galaxy survey that it's doing. It's basically the center of our galaxy goes right overhead the Murchison Array. So they're looking at this thing in between 70 and 270 or 280 megahertz, looking at the galaxy to see what they can spot. And one of the things they found was a collection of about 27 supernova remnants. And these are not brand new supernovae. These are actually older ones that have dimmed down quite a bit. So the younger supernovae, when these things blow up, they're very bright in both optical and in higher radio frequencies. And the older ones, as a supernova dims out, it dims down pretty quickly. You don't see it anymore, but they're still there. There's still a remnant expanding out into space. And so the Murchison Array took a look at and found about 27 of these things hidden sort of against the backdrop of the galaxy. So they're a little bit hard to spot, but they were able to find this and took a look at them. And what they're doing is now characterizing what happens to these supernova remnants as they age and expand out. before they get to the point like Vela, which is really expanded out, but these are still got some shape to them. They're taking a look at them to see what's happening as they expand out into the intergalactic medium.
It's kind of ironic, like we live in a galaxy and yet we really haven't had a chance to see a lot of supernova, especially in our lifetime. I don't think there's been a bright supernova in our lifetime. The closest one was like 1987A.
Right.
And so you can't study any of these really new ones. You've got to study these older ones, these dimmer ones. And it's kind of, it's amazing to sort of think that they're all out there, and it just takes a certain kind of wavelength to be able to see them.
Well, there's a lot going on in the low frequency range that people knew was happening, but they didn't have any way to detect it because the stuff is so hard to do. I mean, the low frequency array in Europe, for example, is a little bit higher frequency range, but they have to do a heck of a lot of processing to be able to pull data out of what they're looking at. So this thing is, located out in the middle of nowhere in Australia. They still do have some radio frequency interference. There's a lot of mining that goes on in the area, and so these big trucks will go by and their radios are on, and so those will interfere with the array as well, although not as much as they expected it to. But that's one of the things they warned us about. The reason I got involved is MIT Haystack. I'd been doing some research or doing some outreach for them, and they wanted to make a movie about this, and it was still being built. And so we basically went over there and shot a little 9-minute video. This was in 2009, and you can still go over to their website and see it, talking about this array and what they were hoping to get with it. One of the other things that they want to do is be able to use this to detect deuterium in our galaxy. And the amount of deuterium that is there would then tell them, a little bit more about stellar formation activities in various parts of the galaxy, how much deuterium gets eaten up by that. And if there's a place that they find in the galaxy that has a lot of it, then, that tells them something about the stellar evolution process that happened there. So that's one thing I know they're looking for.
And I think, for a lot of people to sort of put this in context, like this is considered a precursor of the square kilometer array, which is also going to be built in Australia. And so this is when the square kilometer array comes online, and it is literally going to be 1 whole kilometer of telescope.
Yeah, and this will be part of it too, actually. It's going to be the giant area in the outback just filled with telescopes. And they don't look like telescopes. I don't know if you've got a picture of it.
Yeah, I put a picture up while you've been talking, yeah.
Yeah, these things look really strange. When you first look at them, it looks like something that some kids built, and they're just really cool to look at. But here they are out there doing cutting edge astronomy. Yeah.
Yeah. One of the other things that's really interesting to me is it's going to be able to perceive, or can perceive, a part of the sky that very few other instruments can, which is right near to the beginning of the universe itself, in this age of reionization, when the first stars were lighting up the material all around them. There just aren't a lot of instruments that are able to see into that time, and yet what looks like a fairly humble telescope in the middle of the outback of Australia is actually one of the most sensitive instruments to be able to perceive this time. So you guys got a chance to actually go and look at it up close?
No, actually, I didn't. I was able to get some footage that other people had shot of the place where they were deploying it. And they sent us a whole lot of footage. And one of them, there's a lot of animals that live out there. And so there are these lizards that go out there and climb up your back because they'll get up on the tallest thing around. And if you're a human being, you're usually the tallest thing out there, and they'll crawl up. So we actually threw one of the lizards in the opening of the video. Thought it was really cool.
Oh, that's cool.
You mentioned the epic of reionization. That's like the holy grail of everybody's observation. And to be able to get it in as many frequency ranges and as many wavelengths of light as you can get will really tell us a lot more about what was really going on at that period in the universe.
It's funny, like I think, everyone is so excited about the pretty pictures that come from like the Hubble Space Telescope and things like that. But these radio telescopes, we've got a similar instrument in Canada, the CHIME instrument. I don't know if you've, it looks like a rad snowboard park, and maybe it is in the wintertime. I'm not sure when the snow falls, but has been observing all of these fast radio bursts around the sky. It's like the perfect machine for detecting these fast radio bursts, and yet it's a fairly humble collection of radio telescope instruments that are just perfectly tuned to solving
It kind of
these.
reminds me of the one that Dame Jocelyn Bell actually used when she was doing her pulsar work. It just looks like a fence, and I got a picture of it from my book, and it just looks like this fence, and it's very humble looking. The thing about these though is radio astronomy goes all day and all night. It goes 24/7. And so LOFAR and things like the MWA and the SCA are just going to be catching transients and radio bursts and all kinds of things 24/7. And the only thing that's really going to interfere with them is, some sort of radio frequency interference, or the electricity goes out or something like that. Otherwise, they're just out there 24/7 doing their thing.
Yeah, and again, as you said, the farther you can get away from the cities, maybe the far side of the moon would be a good spot for a future gigantic radio telescope.
Yeah.
Another reason to go back to the moon. Super cool. All right, you're the one who's on my screen. So, Carolyn, if people want to find out more about what you're working on, what you're doing, where can they go?
Go to thespacewriter.com. I write my blog there, and I make little announcements. And if you follow me on Facebook, I'm on there as well under the name Cece Peterson, and I'm at Space Writer on Twitter.
And I know most recently you wrote on this possibility of planets around supermassive black holes, and that's something that we covered on Universe Today as well. Pretty exciting piece of news. We talked about it here on the Space Hangout last week as well. What are you working on next, do you figure?
Right now I'm working on a video for a group of people in Hong Kong.
Oh, cool.
Yeah, so that's why I'm not going to the AAS meetings. I'll be filming that video.
Are you actually going to Hong Kong, or are you going to be?
I've already been there once.
Okay.
We had a meeting right about the time all the riots started. So
There you go.
That's got to make it tough to get work done.
It was pretty exciting.
Yeah.
Well, not the riots, but everything else. Yeah.
David.
Well, see, what haven't I been writing for recently? Let's see, Universe Today, Sky and Telescope. I have a Sky and Telescope article coming out in March on traveling with the astronomy gear, how to not get your stuff confiscated like I almost did in Morocco when you bring your stuff in. I have an article.
It's a telescope. Not.
Hey, I got a story. I got a story out of it. So I'm writing one for EOS magazine, thanks to Kimberly Cartier, who recommended me on binocular astronomy.
Oh, great.
And I'm working on another book. Actually, it's at copy editor right now for it. This is Backyard Astronomer's Guide to the Deep Sky. And it's going to have my own little homemade sky maps in it that I've been working on, crossing my eyes over. I asked them for another week so I could review these before I put them all on Dropbox and hand them away. But it's going to be neat. It's kind of an interesting little experimental, but it's going to be something a little different than most deep sky guides.
So I'm going to be putting this to the test, David, which is that I'm going to be operating this observatory thanks to OPT again, and I'm going to be trying to use the book to see if I can get it to. You seem nervous.
Well, like I said, it's a little experimental.
Yeah, I know.
The way it's laid out is a little different than the idea is we're going from your idea of what's in the sky tonight.
Yeah.
And it is meant to be, I'm still trying to push them to get it to be a wire-bound binder.
Yeah.
Like the mock-up I have with everything, that you can just lay it out flat and use it out there. So
yeah, so I'll do some beta testing for you.
All right. You've probably seen it up there on Google Drive. I think I've shot you a link before.
Yeah, I got a copy of it. So I'll
right.
I'll try and just use it and then see if I can. I'll give you some guys some feedback.
All right.
Moya, what do you got?
Well, if you want to follow me on Twitter, you can find me at GoAstroMo or my website moyamcteer.com. I recently hosted my very first show at Caveat, which was really exciting, and I published a piece about my research in Supercluster. And I'm trying to join the author club because you all seem so cool. So I'm working on a book proposal right now.
Oh, right on.
Are
you allowed to talk about what your proposal is yet, or is that still?
I think so. It's going to be a book about the formation and evolution of the Milky Way, but I want to write it from the Milky Way's perspective as if it's writing its own autobiography.
Oh, that's awesome.
That's cool.
That sounds great.
Thank you.
And so for me, I just a couple of days ago, no, yesterday, we released our latest video all about the raw material on Mars, and we actually produced a periodic table of elements and sort of explained what is the evidence for each one of the elements that we know of on Mars so far. So where the chlorine comes from, where the bromine comes from, etc. So a lot of people really enjoyed it, and I like that. And then also, I've got an interview with our good friend Paul Sutter coming out on Friday, where we talk about the cosmic crisis in cosmology. So stay tuned for that. And so it'll be a blast from the past talking to Paul Sutter, because he's so busy now. All right, I'm going to put everyone back on my screen here. There we all are. So thanks everyone for joining us today. Thanks to both Nancy's, Graziano and Atkinson, for conspiring together to bring Charlie Duke here on the show. Could anyone tell that I was freaking right out in interviewing him? That was the most incredible thing ever. So I
was pretty excited about that.
Yeah. You guys should have jumped in and helped me out. I was, I was struggling. That was incredible. So
you're right. In the SLS is launching just a few months next year. First SLS launch.
Did you see the tested hydrogen tank that they tore in half?
Oh, I saw that.
I heard about that. I heard about it.
Yeah, pretty great. Anyway, thanks Nancy's. I really appreciate you letting me go through that. And thanks to all of the fans, all the moderators, everyone watching, and we will see all of you next week.
Bye.
Bye.
Which button now do I press? This one.